All right. Good evening. You're welcome to today's class on physics. And the topic we will look into is work, energy, and power. Work, energy, and what? Power. Work, energy, and what? Power. Work, energy, and what? Power. Have you done that in your school? Have you? So you should know it now, right? So without wasting time, I want to drop one or two questions. I want us to submit in our next lecture on work, energy, and power. So after the question, I'll use the remaining time to introduce the topic. Then we'll call it a day. We've been here since morning. It's not easy at all, right? So let's see what we can make out of this topic. I'll drop some questions. Now, we'll take it off from there. All right. Take down these questions. Question number 1. Question number 1. A stone of mass m kilogram. A stone of mass m kilogram is held h meters above the floor for 50 seconds. A stone of mass m kilogram is held h meters above the floor. H meters, H. You write it. For 50 seconds. Full stop. The work done in joules. The work done in joules over the period is. The work done in joule over the period is A. mH. mH, yeah, mH, small letter, mH. B. mgh. B. mgh. C. mgh over 50. C. mgh over 50. D. 0. D. 0. The second question. A ball of mass 0.1 kilogram. A ball of mass 0.1 kilogram is thrown vertically upwards. Is thrown vertically upwards with a speed of 10 meters per second. With a speed of 10 meters per second from the top of a tower 10 meters high. From the top of a tower 10 meters high. Full stop.
With a speed of 10 meters per second.
A ball of mass 0.1 kilogram is thrown vertically upwards with a speed of 10 meters per second from the top of a tower 10 meters high. Full stop. Neglecting air resistance, comma, Where are you?
From the top of a tower.
10-meter high. Are we on this same page? Good. Neglecting air resistance. Neglecting air resistance, comma, its total energy before hitting the ground. Its total energy before hitting the ground is A, 5 joule, just 5J, B, 10J, C, 15J, D, 20J. Then open a bracket, write G is equal to, that is acceleration due to gravity. G is 10 meter per second squared. G is what? 10 meter per second squared. Number 3. If a pump is capable of lifting 5,000 kilograms of water. If a pump is capable of lifting 5,000 kilograms of water through a vertical height of 60 meters in 15 minutes. If a pump is capable of lifting 5,000 kilograms of water through a vertical height of 60 meters in 15 minutes, comma, the power of the pump is A, 2.5 times 10 to the power 4 joule per second. 2.5 times 10 to the power 4 joule per second. B, 3.3 times 10 to the power 3 joule per second. 3.3 times 10 to the power 3 joule per second. C, 3.3 times 10 to the power 2 joule per second. 3.3 times 10 to the power 2 joule per second. D, 2.5 times 10 to the power 5 joule per second. 2.5 times 10 to the power 5 joule per second. All right, let's go. We'll stop here for the questions. Let's go over to the topic of today: work, energy, and power. Work, energy, and power. Work, energy, and power. Sit up. If you're tired, stand up. The way you sit in class affects your understanding and assimilation. The best way to address tiredness or maybe tired of sitting one place is to stand up, walk around, okay? While still listening to the lecture, you can walk around. That one is acceptable. But sitting down and be putting your head on the desk is not acceptable, okay? Or relaxing too much like this is not the best way to sit in the lecture hall. So please take note of that. Now, let's continue. So work, energy, and power. Now let's start with work. What is work? Council, what is work? What is work? Or simply put, when is work said to be done? No idea. Is what's work? I can't hear you clearly. Speak up. Work is what?
Work is said to be done when effort is added to it.
When effort is what?
Added to it.
Added to what?
To
To
work.
work. How can you use the same what I told you to define in? How can you put it back in definition? What is work? Act of doing something. Okay. Yeah. On a layman's what? Understanding, right? In layman's term. Here we are here. Am I not working? I'm working. If I go downstairs, carry a gallon of water upstairs, I am working. If I carry this chair and put it somewhere else, I'm working. If I wash my plate, is work. If I wash my clothes, is work. Two of us now. But in physics, let's define work with respect to physics or mechanics, specifically mechanics. What is work? Okay, in physics, work is said to be done whenever a force moves a body over a distance in the direction of the what? Force. In physics, work is said to be done whenever a force moves a body over a distance in the direction of the what? Force. In physics, work is said to be done whenever a force moves a body over a distance in the direction of the what? Force. Good. Work is said to be done whenever a force moves a body in the direction of the force over a distance in the direction of the force. Does it make sense? Now let me explain. As I am here now, and I push this table or push this stool from here to this place, or carry the stool from here to this place. In physics, work is what? Done. True of us, because I push it the direction of this force. I am applying this chair has been here. I apply force on it, right? This force I apply on it. The direction of the force is what? Here, right? And this chair moves in that direction over a distance from here to here. I have done what? Work. A work has been what? Done. Now let me ask a question. If you look at this wall and push this wall from morning till 6 p.m. from 8 a.m. to 6 p.m. will this wall move? I will pushing it though. I will be sweating. I get tired. I eat breakfast. Come again. Push it though. this wall remains here, and I push it till night, I'll go and say, hey, I walked today. I'll sit down and be enjoying. Did I walk? Did I walk? I didn't do any work. Even though I was sweating. I didn't do what? Any work. I may be sweating after this whole thing, but for work is what? Zero. Do you know why? This wall remain where it was when I started the pushing. There are no movements. Because of no movement, no distance covered. So work done is what? Zero. I didn't do any work. It's shocking. How are you? Is it clear? This wall did not move. So I did no work. Now, let me ask another question. If I stand here, this two now. I'm here. I carry this two from the ground, from the floor, and lift it up. Put it on my head. Hold it like this, and stand like this from morning to from 5 p.m. In fact, from this minute till tomorrow morning, and in the morning, I'll be sweating, right? Then I'll put this stool down and say I have walked. I'm gonna be enjoying. Did I walk? Did I walk? Cash, did I walk? Speak. Did I walk? Did I walk?
Yes.
Huh?
Yes.
I walk. Did I walk? Huh? Why did you say that I walked?
Because you carried the share up to your head and you were holding it. Assuming you did not shift the share, you are just standing and the share was just here. And you did not do anything. But since you carried the share up, you are walked.
Okay, two things happened. One is that I carried it from the floor, placed on my head. I walked and I also did not walk. In terms of lifting the chair from this place and from the floor and put on my head, I walked. Because it moved a distance. You applied the force on it and lifted it, right? It moved the distance and I placed it on my head. I walked back. The work I did was carrying the chair on my head, to my head. Lifting the chair from the floor and put it on my head. That's what I did. But by virtue of staying one place, in terms of movement, I did not do what? Any work. Am I completing? So the work I did was just to lift the what? The chair. Am I completing? Now, but if I stay there, let's assume I stay there, carry it on my head, and be saying I was sweating. I say, hey, I walked. I carried something on my head. I didn't do any work, but I carried it on my head. Am I completing? I did no work, but I carried it on my head for hours. Two of us. Now let's assume you are the one standing. You are standing like this, or you are sitting like this. I carry this chair. Me, you are sitting like this, so the way you are, I carry the chair. Come and place on your head. And you said like this till tomorrow morning. Did you do any work? Who worked? The work was done by me. I worked, but I may just carry this chair and put on her head and just go without stress. But she may be there for hours. His neck will pain her. She'll be sweating. But at the end, she didn't do any work. It's me that worked. She didn't work. Am I completing? But she didn't move a distance. It's me that covered the distance by carrying this thing in the direction of the force where I was going to, where I carried it to. Is the person that did what? Worked. That's what work is all about. So work is said to be done whenever a force moves a body over a distance in the direction of the what? Force. The work is said to be what? Done. Now, With this now, how do you now measure work done? In that case, now we define work done. Work and work done are not the same. No, are you aware? Work done is different. Now, what is work done? When you want to measure the work, that's when you talk about work done. I'm not communicating. Carrying this from here to here is work. True of us. But now, what is work done in carrying here this chair from here to here? That's where calculation comes in. So what is now work done? Work done is nothing but force times displacement, not distance. Displacement, okay? Because displacement is distance and what? Direction. Remember the definition of work. That work is said to be done when a force moves a body over a distance in the direction of the what? Force. That distance and direction is what? Displacement, right? Distance and direction is what? Displacement. So mathematically, work done is now equal to what? Force times what? Displacement. Am I communicating? So work done is what? Force times what? Displacement. Work done is what? W is what? Force times what? Displacement. Does it make sense? You can use S, you can use D, anyone is okay. Let me use S. Times what? Displacement. Is it clear? Now, force is in what? The unit is what? Newton. The unit of displacement is what? Meter. So work is what? Newton what? Does it make sense? Work is what? Newton what? Meters. But because of the work of Joule, they gave it what? Joule. Am I communicating? So actually, Joule J is certain as what? Newton times what? Meter. Am I communicating? Joule, which is J, is certain as what? Newton, which is N, times what? Meter. That's what I want you to know. Does it make sense? Good. Now let's look at work done in various situations. Work done in various what? Situations. We want to look at work done in lifting a body. Work done in lifting a body. Then B. Work done on a falling body. Falling, or work done by falling. A is what? Lifting what? A body. Example, what I did here, right? Then B is what? Falling what? Body. These two ones are under what? Gravity. True of us. Good. Now, this is where we want to. What's time? Okay, we still have like 14 minutes to go. What is it? You want to go? Okay. I told you that it's 6 p.m., 9 to 6 p.m., no time. Now this thing now, when you are lifting a body, or when a body is falling down, all of them are under what? Gravitational what? Field. Am I communicating? Gravitational what? Field, or simply force field. Gravitational what? Field. Because G plays a role. Two of us, when we are lifting a body and when a body is falling down. When you're lifting a body, is it working in direction with the gravity or is it against gravity?
Against gravity.
Huh?
Against gravity.
Can't see. You don't know. When you're lifting the body, is it working against gravity or in direction with gravity? What direction does gravity work? Gravity. What direction? It goes up. Gravity goes up. What direction? Down, right? That's why if you throw something up, it do what? Fall. So gravity is this direction. So if you are lifting this chair, are you working against gravity? Yes. Because gravity is acting down, you are lifting it what? Up. Now, what a body that is falling from top of a tree or top of a ladder or whatever, is it working against gravity or in line with gravity? Yeah, because gravity is the what? So when a body is falling down, its acceleration is positive what? G. Positive what? G. True or false? Because it works in direction with what? Gravity. The acceleration is using is what? G actually. But it's positive because it's in direction with what? G. But if a body is going up, you are throwing a body up, you need more energy to push a body up. True or false? True or false? That means you need more energy to go against what? Gravity, to conquer the what? Gravity. So the body is doing what? Working against what? Gravity. So G, the acceleration with which the body is going up is negative G. Am I communicating? Is negative what? G. We'll see make use of this thing very well when we go over to motion. Okay? Motion under what? Gravity. But because of the nature, you know, when work is involved, there's a motion is the true of force, a distance is covered, true of force. Now, depending on the type of motion involved, but the point that a distance is what? Covered. The force is active, and a displacement is what? A distance is covered, and in particular what? Direction. So that's why we are talking about this. Now let's go. Now, if you lift a body, am I communicating? You can listen or you can write. Anyone is okay. If you lift a body through a height, I think you can write, so you can appreciate it better. If you lift a body of mass M, remember we are under what? We are talking about work done in the force field or under gravitational what? Work done under gravitational. I thought that we look at work done in different situations. This is work done under gravitational what? Field or force field. The aim part of it is lifting a body up. Am I communicating?
Yes.
Good. Now, if you lift a body up, what is the work done? That's what we want to talk about. Now, so lifting a body, we say we want to derive something now. We want to derive the formula for work done. You remember this one we say force time displacement is just translational what? Motion, right? Movement in this direction, right? Straight, right? When you push a body or dry a body, this is the one we talk about. But that's what the force times what? Displacement. But now when we talk about under gravity, there's a different formula. Even though it has something to do with that first one we gave. We derive it from the first one we gave. Now, lifting a body, if you lift a body of mass M, if you lift a body of mass M, just like this chair now I lifted, through a height H, through a height, comma, H, are you aware that this chair has weight? You must conquer this weight before it can lift it up. True or false? Do you know why I was able to lift this chair up? I conquered the weight of this chair. I also conquered gravity. Two of us, before I lift up, two of us, I conquered the weight of the. Of course, what am I even saying? Sir? By conquering weight of this chair, I've conquered gravity. What is weight? Weight is what? Mass times what? G. It's not true. Weight is what? Mass times what? G. True or false? And weight is what? Force. It's not true. Now, by virtue of being able to lift these two from this place, I have conquered the weight of this chair. That means I applied a force that is greater than a pulling force, because I pulled it from the ground. I applied a pulling force that is greater than the weight of this chair. That's why I was able to do what? Lift these two. Let's assume what is on the ground, on the floor here, is a tank, big GP tank, and only me. We want to lift it up. Can I do that? Do you know why? There is no amount of weight, force, pulling force I will apply on that GP tank to lift it up. I cannot do it. That means the weight of the GP tank overcome my own pulling force. That's why the GP tank could not be lifted up. But if you get this vehicle now that can lift things up, once they chain it well, they will apply a larger force on it that will overcome the weight of the what? GP tank. They will be able to do what? Lift it up. Does it make sense? Now let me continue. So I said, where did I stop?
Through your height, page.
No, start from the beginning.
If you lift a body of mass M through a height, page.
Now, if you lift a body of mass M through a height H, a pulling force must be applied to overcome the weight of the what? Body. True or false? True or false? A pulling force must be applied to overcome the weight of the body. What this means is that for us to lift, what this means, write it down. What this means is that for us to lift the object vertically upwards, work must be done against the force of the what? Gravity, or against the weight of the what? Body. What this means that for us to be able to lift this body vertically upwards like this, work must be done against what? Force of gravity, or against the weight of the what? Object. True or false? True or false? We must do a work against this weight. And what is this work that must be done against this force of gravity? Remember, this work is still what? The work is still what? W is equal to what? Force times what? Displacement. Right? Right? Good. Force times what? Displacement. This is the work that must be done. But because you are lifting a body from the ground to upward, this force now is the weight. True or false? This force now is, we must apply, is what? Is what? M what? G. Do you know what is mg? Do you know what is mg? Do you know what is mg? Do you know? Aizu? Do you know what is mg? Because it's against what? Gravity. Am I communicating now? Okay, let me now. What is force? By definition, force is what? M. Mass times what? Force is what? Mass times what? Hey, what's going on here? Talk now. Mass times what? Acceleration. In the linear motion, force is what? Yeah. What is force? In the linear. Yeah, keep quiet now. Don't keep quiet. I asked this question for me to know whether you are following. If you keep quiet, it gets me confused. Force is what? Mass times what? It's acceleration in MA in a linear what? Motion. But here now, because gravity is concerned now, this A will change to what? G, right? So here force is now equal to what? M what? G. Am I communicating? Times. Are you tired? Should we stop? We should stop.
Yes.
We should stop. Stand up. Stand up, you. Walk around and listen. Now, this is mg now. This force is now equal to what? Mg. Now, because we are talking about height, the displacement is now the height through a force through which you lifted the what? Body. So this S will change to what? Change to what? H. So if this H, S changes to H. Now, work done in lifting this stool or the body from the floor over a height is now equal to what? W is now equal to what? Mg what? H. So you lifted the body from the floor to a particular height. The work done is what? Mg what? H. Is it clear? Is it clear? Good. Now, G is what? Constant, right? In a particular location anyway. M is mass of the body. And H is what? Height through which you carry the body up. G is normally placed at what? 10 meters per second what? Square. Sometimes you may see 9.8, right? Now, this is the formula for work done in lifting the body from the floor. Am I communicating? Am I communicating? Now, put down this question. Put down this question. A boy of mass 50 kg. A boy of mass 50 kg, 50 kg runs up a set of steps. A boy of mass 50 kg runs up a set of steps, 1, 2 steps of total height 3 meters. Of total height 3 meters. Find the work done against gravity. Find the work done against gravity. What's the answer? After this, we'll go to in our next class. We'll start from falling body. What's the answer? It's simple. 150 what? 150 what? Check well. The question says a body of mass 50 kg runs up a set of steps of total height 3 meters. Find the work done against gravity. What is the work done? Going against gravity, what's the work done? What is the formula? Speak out now.
Force and displacement. MGH.
So what is the answer now? What is M?
50 kg.
What is G? Even if you are not giving, you should know that G is, I told you that G is constant. What is G? Now put it now. Then what is height? What is height? I don't like being keeping quiet. If I ask you, what is height? Say it. What? 3. Then solve it.
1,500.
Please, this thing is not easy to be shout from morning till night. Please, if I ask question, say something. Stop. Don't keep quiet on me. Talk. Please. Talk. Answer it. Don't keep quiet, please. I beg you. So the answer is what? 1,500 what? What are you saying? Jewels, please. Or is jewel right? Good. Is jewel or Newton meter? Two of us. Just leave it at jewel. It's okay. But if you start breaking, remember what you need in dimension. Remember, if you break it down, you get something, right? This is what? Kilogram. This is what? Meter per second. This is what? Meter. How is it meter now? Right? Let's stop here for today, please. Any question? I ask. What is the what? Difference between mass and weight. Mass of a body is the quantity of matter in the body, and mass of a body is what? Constant. Mass of a body doesn't change. Am I communicating? Mass of the body is constant, it doesn't change. But weight is force of attraction on a body due to gravity, right? And weight of a body has a formula. So weight is what? Mass times what? Acceleration due to what? Gravity. But gravity is not the same in every way. Hope you know. Are you aware? Because gravity is not the same in everywhere, weight of a body changes. True of us, depending on where the body is, right? So weight of a body can change, but mass of a body doesn't change, right? So weight of a body is mg. Am I communicating? So between weight of a body and the mass of a body, which one is a fundamental quantity and which one is a derived quantity? Mass is what? Does mass has formula? Good. But weight is what? Derived. So weight is what? Derived. The unit of mass, the SI unit of mass is what? Kilogram. But the SI unit of weight is what? Is what? Is what? Hey. Is what? Newton, please. I'm giving you up to how many differences now? Are they up to 4? I gave you, by definition, I gave you the difference in their what? Definition. That mass is the quantity of matter. Weight is what? Weight is what? The force of attraction on the body, right? Gravitational force of attraction on the body, right? I gave you different based on the type of quantity they are. Mass is a fundamental quantity. Weight is a derived quantity. I gave you whether they are constant or not. Mass is constant. Weight does what? Changes. Why does weight change? Because acceleration due to gravity does what? Changes. 4 differences now. And I also give you another difference based on their SI unit. Weight, SI unit is what? Newton. Mass, SI unit is what? Kilogram. They may ask in your work 5 difference between or 10 6 difference between weight and the what? Mass. You should be able to do what? Answer it. Is it clear? Is it clear? So let's stop here. Any other question? All right. In absence of any question, please let's call it. Is it a night or a day? So hope you enjoyed today's class. Why? You are tired. Yeah, now it's normal now. But by enjoyment, I mean, did you understand the class, the lectures? That's what I mean by enjoying. Are you here for enjoyment? You are here to learn, and to learn, you must sacrifice something. True of us. So when I say enjoyment, I don't mean jolly. I mean understanding what we did. So please go. I gave you assignment in mathematics, right? Gave you assignment in what? Chemistry. I gave you assignment in what? Physics. Please solve the assignments. Wednesday, we look at the assignments and take it up from them. Remember Tuesday, Monday, please come on time, Tuesday one. Oh, Monday now. Monday come on time, 4 p.m. Okay? All right. All right, thank you very much. God bless you.